Here's the lab setup for an absolute zero lab. So what we're going to do is we're going to measure the pressure and temperature, at five different temperature baths, including the room temperature. And we're going to use this uh, tool. It's called constant volume gas thermometer. Okay, because this metal bulb has certain quantity of helium gas, and when you give this in thermal contact, its pressure changes based on the temperature, right? And just by measuring the pressure at various temperatures, you can find out the absolute zero temperature by extrapolating the graph. So that's the technique we're going to use. So first I will begin with measuring its pressure. So remember, there's some helium gas inside. So first, the pressure at room temperature. So it's sitting on at room temperature, and its pressure is this. This pressure gauge measures the absolute pressure instead of gauge pressure. It can measure the absolute pressure in psi. So it's about you can see 15.5 psi, right? And the room temperature is 23.3 degree Celsius, right? So that's the pressure and temperature data at room temperature. Now I'm going to measure the pressure at by submerging this in a hot bath. So I just have to dip it, completely submerge the bulb into the hot bath. And as you can see, the pressure is increasing, and that pressure it takes some time to reach the thermal equilibrium, but it seems that the pressure at this hot bath temperature is 17.5. Okay, and there is some plus and minus uncertainty, but 17.5 is the pressure of this gas bulb at this hot bath. So let me measure the temperature. So temperature of this hot bath, it may not be 100 degree. So temperature of this hot bath is 78.4 degree Celsius. Now the pressure of the given gas at ice cold water is, as you can see, 14 psi. Okay, 14 psi. And the temperature I'm measuring is temperature of the bath is about 2.2 degrees Celsius. So here's the next one. So this is, we're measuring the pressure at dry ice. So it's the ice, as you can see, made from carbon dioxide. So it's called dry ice, and its temperature is negative 76 degrees Celsius. I have already measured it. And as you can see, the pressure in at dry ice is about 11 psi. Okay, 11 psi. As you can see, the pressure has decreased significantly, and measuring the pressure at dry ice is always a little tricky, and it gives you huge uncertainty because, as you can see, because you can't really submerge this gas bulb completely inside the dry ice, right? As you can see, it gives you a lot of uncertainty. So finally, our last data point is taking the temperature, pressure of the given gas bulb at liquid nitrogen. So this is the coldest temperature we have in our lab, and its temperature is negative 196 degrees Celsius. Okay, that's the liquid nitrogen temperature. So you can, this is basically air actually, liquefied air, basically nitrogen, and you have to be a little careful with that. So basically this liquid nitrogen is boiling basically. Its boiling point, right, is it boils at negative 196 degrees Celsius. As you can see, pressure is dropping rapidly, and you can completely, you may have to trap it a little bit because it might stop sometimes. And as expected, the pressure at liquid nitrogen, right, is the minimum pressure. So it's about 4 about 4 psi. Okay, 4 psi at negative 196 degree Celsius is the temperature and pressure data. So if I dip this balloon, inflated balloon, in liquid nitrogen, right, since you are reducing the air temperature significantly, as we expected, the balloon will shrink. This volume will decrease significantly, as you can see. Right. As you can see here, it has almost shrinked. And if you now just keep it in at room temperature for a while, as you can see, it quickly actually retains its original volume, right? As you can see, and they can go back and forth. And you can explain that using ideal gas law. PV is nRT, right? So let me show you one more time. So you can shrink it. You can completely shrink it, right? And you can also hear that sound. Now is coming back to its original volume quickly, as you can see, right? Because it's now back to the room temperature bath. So as you can see, and you can explain that using the ideal gas law.